So today we are going to talk about transformations, in particular reflection in graphing radical functions, which are in general, for now, so far we have seen functions of this type. Okay, let's start with an example. So the question is always the same. First, we are going to graph the function, and then we are going to compare to the parent graph, and then we are going to state the domain and range. Now, let's remember, to graph a function in general, we do the following. First, we make a table of functions, as in step 1, and then we plot the points according to the table, and then we connect the points so we have the graph. Okay, let's do these one by one. Now, first of all, the table. Okay. Now, for x is 0, y is minus 2 square root 0, which is 0, because square root of 0 is 0, and 0 times minus 2 is 0. For x is 1, y is minus 2 times square root of 1. The square root of 1 is actually 1, so it's minus 2 times 1, which is minus 2. So let's write these down. For x is 0, y is 0. For x is 1, my y is minus 2. For x is 4, y is minus 2 times square root of 4, which this one is 2. So it's minus 2 times 2, minus 4. So if x is 4, then we have minus 4 for y. And for x is, say, 9, y is minus 2 square root 9, which is minus 2 times 3, which is minus 6. So we have minus 6 for 9. So this is our table. So the ordered pairs, the coordinates of the points are 0 to 0, 1 to minus 2, 4 to minus 4, and 9 to minus 6. You had better have 4 points at least. Alright, don't forget this one. Okay, let's plot the points. Okay, now we have 0 to 0, which is here. Then we have 1 to minus 2, so it's here. Then we have 4 to minus 4, it's here. And then we have 9 to minus 6. So if we draw our graph with green, it will be something similar to this one. Okay. So this is not a nice graphing, but yeah. So this is how we plot the points and draw the graph by connecting the points. So this is our graph, y equals minus 2 square root of x. To compare our graph to the parent graph, first of all, let's use a computer-generated graph. Now here, the graph with the blue color is the parent graph, y equals square root of x. And the graph with red color is our graph, which is y equals minus 2 square root of x. Now we are going to compare our graph to the parent graph. Now, if the number in the front is a negative number, then we are going to say that our graph is reflected as in the mirror. Okay, it's reflected as in the mirror through x-axis. That's what we are going to write. It is reflected through x-axis, and what is more, and is, okay, the graph is stretched. So our graph is also stretched, meaning it became larger than the parent graph. You see the parent graph, it is not that far away from the x-axis, whereas our graph, on the other hand, is quite far away from the x-axis. Actually, it is double the size of the parent graph. So we say that it's stretched and it is reflected through the x-axis. For the domain and the range, we just look at the graph. Domain is the x values, right? So domain is the x values such that now we use the x values here, which are positive starting from 0. So we say x is greater than or equal to 0. And for the range, which is the y-axis, to be precise, are the negative values of y. So we are going to say y values such that y is less than or equal to 0. That's what we are going to write for domain and range. Well, now is your turn. Please graph these three functions. Now please remember, what you're going to do is to make a table of function values and then plot the points you get from the table, and then join the points or connect the points so that you're going to get the graph. And then you're going to compare it to the parent graph. It's okay if you draw the parent graph, and then you're going to state the domain and range. Please do the graphing and show me your graphs.